Till then, Maha, I asked you to write the screenshot, to take the screenshot of some of them. Okay, have you noted that one?
Okay.
No, not yet.
Which one? The
Which one? That
advantages.
why do soap do not work in hot water?
Yeah, I wrote it.
You have noted that one?
Yeah.
Okay.
And then the
Ah,
cleaning action also done.
this one you have
Yeah,
noted?
that is also done.
You have noted?
Yeah, in the
Because you
last.
take the screenshot.
No, I noted it
Okay,
after
write
the class
down.
ended.
Okay, noted. Have you taken the screenshot of this one? You done
Yeah,
this
I
one
did
also?
this too. Yeah,
Oh, very good. You are so sharp. So you have noted each and everything.
yeah,
And this one also, cleansing action.
yeah.
And this one also. So let's till then the other students are joining. So let's start doing some questions.
Okay.
I have to wait for those who are late. Till then, the students are joining. Okay, let's have some questions related to this one. Just a minute. Not from the soap. Let's have the chapters from the whole chapter. Okay, is it okay?
Yeah.
Let's have.
I mean, I haven't learned the whole chapter yet.
Let's practice. If you have not, we will practice. We are not saying you are in the test. Not you are on the test. We're just preparing for the test. Please do this one. Try to solve this one. Who is this Limi? Mariam. Mariam भी अलग ही लेवल की लड़की है. Mariam, turn on your camera.
Yes, sir, 1 minute.
Sorry, Mariam, do this question please fast.
Yes, sir.
So, do you remember this one, Mariam? How will you convert this one? Ethanol to ethene.
Sir, I'm still doing it. 1 minute.
Still doing it. It's taking 1 year to complete this one. Na? Smaha, you done?
So I don't know.
Ethanol, we have studied the dehydration reaction. Dehydration of alcohol. Dehydration of alcohol. Do we have studied this one? Yes, we have studied. So in dehydration of alcohol means removal. What does the word dehydration means? Dehydration means removal of water. Removal of water. So if we are removing the water simple from the alcohol, like this is alcohol, CH2, okay, ethanol. Instead of writing this OH group here, I can write it here also. It does not have any. It is still ethanol. Okay. So for better understanding, I'm writing it here. Okay. Then if I'm adding it to concentrated H2SO4, got it? Then it will remove this water from it. It will form C double bond H, and here it will form C double bond H. Got it? Plus water. So this means the water will be removed. So one valency, one electron of this one electron will from this one will be removed, and then it will form water. So this is ethene. Got it? Got it?
Yeah, but what will be the reaction name? Dehydration of alcohol.
Dehydration of alcohol. Any alcohol, when you pass it with concentrated H2SO4, it will remove the water from it and will form alkene. Yes. And how will you convert propanol to propanoic acid?
Sir, so what about the other equation where we use acidified potassium permanganate?
Here we will use acidified potassium permanganate. It will give you
So,
different product, na?
so
Propanol will
C2H5OH plus 2O pass through KMNO4 CH3COH plus H2O.
that that one it will gives you means alcohol, any alcohol, if you are treating it with the same number of carbons, if it is two carbon alcohol or whether it is 5 carbon alcohol, if we are treating it with alkaline KMNO4, okay, if you are treating it with alkaline KMNO4, then at 443 Kelvin temperature, then it will get converted into alcohol. Sorry, carboxylic acid will get converted. And here I'm writing plus O. You can write it O like this way if you want, and you cannot write it. It's your choice. Don't write it O here. If you want to write, you can write it here. Because this is not O2. It is nascent oxygen, which is in the atomic form, which we get from the oxidizing agent, indicating that KMNO4 is used as oxidizing, strong oxidizing agent. It is not acting as catalyst. It is acting as strong oxidizing agent. Got it?
Sir, that O is not oxygen?
That is an oxygen, but not in the atomic form that we get in the molecular form in the atmosphere. Like
Sir,
during the
so what if
combustion, we
we
use
write
O2, na?
O2?
Yeah, we write O2 for the atmospheric oxygen, but this is not the atmospheric. This is the atomic oxygen that we get from the alkaline chemical.
Sir, but in exam I wrote O2.
It will be cancelled. If you exam, you write it, it will be. Why you write O2? Don't write it. Write it 2O, and you have to write it nascent oxygen. So you will get CH3. Now, the same number of carboxylic acid. It will give you carboxylic acid plus water. What the same number? If you are having 2 carbon carboxylic acid here, so you will be 2 carbon alcohol here. It will be 2 carbon carboxylic acid. 2 carbon.
I'm so stuck.
Yes. Yes, is I'm audible to you? Just a minute. No,
Yeah.
there is a power cut here. So let me let me start the generator. Just a minute. Just a minute. Okay. Just coming back in a minute. Till then, so it's same. If it is propanol means prop means 3 carbon. So in 3 carbon, when we are writing the name of 3 carbon alcohol, because carbon, when we are writing the name of alcohol don't have its own carbon. So for that, the chain will be of 3 carbon, C3H7, propyl, and then OH. And then you add it to O, then it will gives you carboxylic acid. But since carboxylic acid have its own functional group carbon, this COH. So here the chain will be of 2 carbon, C2H5. The chain of 2 carbon, the chain formula is CnH2n plus 1. Like alkane has general formula CnH2n plus 2. But if you are writing the chain formula, so it will 3 carbon chain, so it will be C3, double of this one, 6, and then plus 1, C3H7. So same here it is C2H5 and then COH. Got it? Got
Yeah.
it? So you have to do like this way. Got it?
Yes,
So it will be carboxylic acid. Got it? So just coming in 2 minutes because there's a power cut. So I'm just let me start. Yes, please, students, dear student, please wait for 2 minutes, okay?
yes,
Where's
sir.
the keys?
Okay, I've turned torch on.
हटिए जरा मम्मी थोड़ा सा बना Yes. Is I'm audible?
Yeah.
Okay. Let it work till then because actually there is some fault in the line. So still the light from the generator is also not coming. There, actually there's some welding work is going on in my home, and because of that, he uses and there's a power cut in the whole line. So let's start. I'm just turning off my camera so that my laptop will use little RAM. Okay.
Okay.
So today we shall be going to discuss the soap and detergents. So you have to take the screenshot. Okay. I'm just going to finish the class in short span of time. Just a minute. So as you know that, Mariam, and I have already explained you that soap, what are soap? Soap are the sodium potassium salt of long chain of carboxylic acid. This is we have already done in the class. Okay, Ayan, do you understand this one? So this, since we have already done this topic, so let me explain you that when we are talking about a dirt. So this can be made up of non-polar substance like grease, oil, okay, which is non-polar in nature, non-polar in nature, okay. And polar substance is one. Polar substance, I have explained you that polar substance is one, like water. For example, like oxygen, nitrogen, fluorine, and chlorine. When they make bond with any other element, like for example, oxygen making bond with water, so it will attract the bonded pair of electron more closer to itself. And you know that electrons are negatively charged. So if it is attracted to something, so it will become slightly negative. Okay, and it will, okay, and this will become slightly positive because its electron are shifted towards oxygen. So electrons are negatively charged. So the negative charge is shifted more closer to oxygen. So oxygen will get negative. And similarly, this hydrogen will get positive because its electron is shifted away from it. So simply it has become positively charged. Understood? So this type of compounds are called polar compounds, like HCl. HCl is a polar covalent compound. Hydrogen and chlorine atoms are there. Okay, this is negatively charged and this is positively charged. So when they are making bond, it will give its electron to this. The electron will shift it more closer to this side, resulting in that result in a very simple manner. If I'm saying that the electron will be shifted more closer to the chlorine, the cloud will shift it more closer to the chlorine. So chlorine will take a negative charge and this one is positive charge. So this type of compounds are called polar covalent compounds. And polar dissolve in polar. Polar dissolve in polar. Polar dissolve in polar. Polar dissolve in polar. And what are non-polar? Like carbon and hydrogen making bond. So carbon is not so powerful that it will attract the bonded pair of electron towards itself. So it will not have any charge. Like it will not have slightly positive and slightly negative charge. So the covalent compounds are like hydrocarbons are, or hydrocarbon chains are non-polar in nature. They are non-polar. So this long chain of carbon is non-polar in nature. This is non-polar in nature. And what if I added this one to with COO minus, CONA or CO minus? So this is the negatively charged, like if I'm having C double bond O and then O minus charge here. So it will be negatively charged. So this negative will be attracted more positive with the water molecule. This will be attracted more easily with the water molecule. So this is the negatively charged and this one is positively charged. Okay, this one is positively charged, so they will be attracted. So this and is called the ionic and. This and is called the ionic and it will be attracted towards the water, and this and is called the non-ionic and. Non-ionic, or we can say that non-polar, or water repelling, or hydrophobic. We can call it hydrophobic and. Phobia means that has a fear of water. This is also called hydrophobic and. Hydrophobic and. Phobic and. This is called hydrophobic and. Got it? You understood, everyone? Understood?
Yeah.
Now, what is going to happen here is that when we are talking to this way, when we are adding this to water and dirt, what happen here is that, like, this is the dirt molecule, and the hydrophobic. What is this? What is this? I'm just making here. Actually, this is the way of bond line structure of representing the carbon chain, long carbon chain. Like if I'm having this long carbon chain, so 1, 2, 3, 4, 5, 6. So 6 carbon can be represented by this one. 1, 2, 3, 4, 5, 6. This is the hexane. The name of this compound is hexane. This is hexane. Yes, I am. Sorry for the delays. Okay, अब सही है, कुछ नहीं होना चाहिए. So that's what we were discussing here. Just the screen is visible to you. So what I'm saying here is this simple, very so so that's why if we are talking here. So the soap and detergent. So soap has this type of features that we can simply say that this is the characteristics of soap that when we are talking or making the structures of soap. So soap is a type of molecule in which one end is hydrophobic end, one end is hydro. This is a carbon chain. Okay, like if I'm making the 17 carbon, if I'm making C17H35 COO minus or Na. So this is the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. This one is CO. This one is C17 is 35. So this type of molecule, this is the hydrocarbon chain that represents the long carbon chain. Okay. Got it? Understood, Mariam?
Yeah.
So let's go further. So this is the norm. So why do soap okay, the soap is the sodium potassium salt of long chain of carboxylic acid, which we called it, and this is made up of ion. Are you there? Ion, are you there?
Yes.
Okay, so we called it soap. So please take the screenshot of this one's ion. Soap is the sodium potassium salt of long chain of carboxylic acid. So this is the COO minus is called carboxylic acid. So done. And why do soap do not work in hard water? They're very simple. That soap do not work in hard water just because when we add soap to the when we add soap COO minus, okay, when we are adding soap to anyone to the hard water, okay. So like for example, if I'm having C17H35 COO minus with Na, and you add it to any one of them carrying hard water MgCl2, so it forms magnesium salt. So magnesium salts are not soluble in water, okay. Magnesium salts are not soluble in water. Ayan, are you there in the class?
Yes.
So please take the screenshot of this one, that why do soap do not work in hard water. Actually,
I took
soap, okay, in hard water, calcium and magnesium means it react with the calcium and magnesium, so it do not react with hard water because it form when it react when it we are adding soap to the hard water, then it simply react with the magnesium present in that one, and then it react with that one, forms come. Okay, so this is going to form, which is we simply say here that it is insoluble insoluble in water. Okay, and it settle down, so it will not form white scum. When we are just having detergents. So detergents are the sodium salt of long chain of benzene sulfonic acid. So this is the benzene. Okay, and HCO3 is sulfonic acid. So when we remove the H from it, and it will form SO3, and we add Na to it, now it is a salt. Now we are adding benzene ring to it. So this will become long chain of benzene sulfonic acid, C12H30. So this is the long chain of benzene sulfonic acid. So like the carboxylic acid is obtained from fat, animal fat. Carboxylic acid is obtained from animal fat. Okay. Carboxylic acid is obtained like COH or CH3. This is obtained from animal fat. But if you are talking about the benzene sulfonic acid, this is the carboxylic acid. So that's why it is also called fatty acid. It is also called fatty acid because fatty acid, on digestion of fat, we get the carboxylic acid. So this is the fatty acid or carboxylic acid is obtained from animal fat. Okay. So when we are making soap, during making soap, preparation of soap, actually fatty acids or the carboxylic acids come from animal fat. Okay. And we made it from ester. So that's a very popular reaction. We called it saponification reaction. That is very important. Saponification reaction. So in saponification, what we do esters and react with NaOH. It will gives you soap plus respective alcohol. For example, if I'm having ester like C17H35 COO C2H5. So when it react with the NaOH, this Na will come attached with this one and will form C17H35. Okay, and then COONA plus C2H5OH. This OH will be attached to this. Got it? Understood?
Yeah.
Got it? So this is the reason. Okay. Next one is. So this one is done. Next one is when we are recording. Now, this we call it saponification reaction. Okay, now if you are talking about the advantages of soap and detergents, okay, Maha, you can leave it out, okay, because we are just going to discuss that one only. So we'll
Okay,
discuss this,
sir.
so you can leave it out.
Sir, in the regular classes, you have to discuss that last assignment, the chemical
Okay.
properties of ethanol and carboxylic acid. We didn't discuss that.
Yes, we will have this one in the next class, don't worry. You can leave.
Okay, thank you.
So what are the advantages of our detergent? So this is very simple, that the detergents can work in hard water. Mariam and Ayan, please take the screenshot of this one. Please take the screenshot that detergents can work in hard water, but the soap do not work in hard water. Okay, do it. Please take the screenshot, and if you want.
Sir, I took.
Yes, you noted, Ayan and Mariam. Have you noted this one?
Sir, I took
Yes.
screenshot.
So डिटर्जेंट क्यों काम नहीं करते हैं हार्ड वाटर में? ये बहुत सिंपल है कि तो सॉरी क्यों काम करते हैं, क्योंकि वो ना जिस कार्बोक्सिलिक एसिड से मिलकर के बने होते हैं ना, वो पेट्रोलियम से आता है, बहुत हार्ड उससे आता है। तो डिटर्जेंट काम करते हैं, बट व्हाई डू द एसिड डू नॉट वर्क इन हार्ड वाटर, सॉरी सोप डू नॉट वर्क इन हार्ड वाटर? तो इसका रीजन, दिस इज अ वेरी सिंपल रीजन हियर, दैट सोप जो है इट इज CH3COO एंड C2H5. Okay, this is a very long carbon chain. Like for example, if I'm having any detergent like CH3COO, okay, and this is a long carbon chain like C17H35COO minus, but its valency is still -1. And if you are reacting with this magnesium, then it will react with that one. It will form C17H35COO whole twice and Mg. So this is a very huge long carbon chain, double of 17, 34 carbon. So it will settle down because it's now this time it will not dissolve in water because this is a very huge carbon chain. When means non-polar end is very large, two times we are going to have in magnesium. This will be C17H35 COO, and there will be C17H35 COO. So there is a huge carbon chain. Because of that huge carbon chain, it will not. Got it? So it will not dissolve. So that's why soap do not work in hard water. So have you taken the screenshot of this one? That soap do not work in hard water. And Ayan and Mariam, why have you closed your camera?
Yes.
Ayan, why are you having camera turned off?
Sir, because I have issues with my camera.
So we have done this one. Next one is that this way already, Mariam, we have already done this one in the previous class, open detergents. Do you remember?
Sir, I was absent last class.
You were absent in that class. So next is that how do soap work? How do soap work? Actually, soap have a very long carbon chain. One end is the non-polar end. Non-polar end. We called it hydrophobic end. Hydrophobic. Phobic water. Water means water. Phobic means which has a fear. Phobic. Phobic end. Hydrophobic end. So this is hydrophobic end, and this one is Na. Got it? So this is Na, and when it react, for example, when we are adding it to water, so this Na is get ionized, but when we are reacting with water, so water get attached with this end, the water molecule get attached with this end, and this end get attached with the dirt, So when we remove the water, because this is non-polar and non-polar is dirt also, this is also non-polar. So non-polar is attracted towards the water, and the polar end is towards the dirt, while the polar end, this is the polar end get attached with the water, and then we remove it, and then we do it. So you understood? Understood?
Yes, sir.
So the polar end get attached with the water, and the non-polar end get attached with the end get attached with this. So this is the way that we do. Got it?
Yes, sir.
So let you how do the soap the cleansing action of soap work? The soap molecule is made up of two parts. One is the polar part, another one is the non-polar part. The polar part is ionic and hydrophobic end and get attached with the water molecule, while the non-polar end is made up of long hydrocarbon chain. Okay, this is made up of long hydrocarbon chain, which is called the hydrophobic end, means water repelling, and get attached with the dirt. It means this and get attached with the dirt. Thus, the cluster of soap is formed, and this is called cluster, which is having one end get in the dirt. Like this is the cluster is formed. Okay, dirt. There are so many water molecules, and they are get attached with the water. Here, this is the COO minus. This is COO minus. So this one end is getting attached with the water. So this is forming here like this way, like this way. This end is getting attached with the water molecule H2O. Na will get diffused, will moving here and there, but. And this together we called micelles. We called it micelles. Dirt surrounded by the detergent molecule. We called it micelles. So the soap micelles are negatively charged. One more thing is that they are negatively charged. How they are negatively charged? Because when we are having dirt this way, dirt, and this one is having hydrocarbon and this one is COO minus. This is the negatively charged. Another dirt molecule is this one. Okay. Another molecule is this one, and this one is also negatively charged, COO minus. So when we bring them by agitating when machines or by pressing it, by beating it, then these negatively charged particles come closer to each other, they repel, and then they comes out. Because of that force, they comes out. The dirt comes out from the cloth by the edge. So here it is being written that the cluster forms and this is the soap molecules are negatively charged due to the presence of carboxylate ion. CO minus ion is called carboxylate ion. At the surface, the repulsion between the similarly charged missiles keep them disperse the solution. Means they come out of the solution. You understood? Please note this one first. Note this one. Also on WhatsApp. Also on WhatsApp. Did this one? Ayan and Mariam, I know that today the students are absent, so I'm going to teach you this one again. And
Okay,
मैं अच्छे से पढ़ाऊंगा अगली क्लास में.